Okay, now we are going to deal with some questions of NCRT of chapter 5. Here are some questions. For first question, give the magnitude and direction of the net force acting on. First part, a drop of rain falling down with a constant speed. Now let us deal with this in paint. There is a ball, not ball, there is a raindrop. It is falling down and there is a force acting on it, that is mg, and is the mass of the drop, and there is also a friction force, air friction, which is acting on it, due to which when this F becomes equal to mg, then net force will become 0, and then acceleration will become 0 and velocity is constant. So as given in the question, the velocity is constant, so acceleration is 0, so net force is 0. Now move on to this next part. A cork of mass 10 gram floating on water. Floating on water means that it can be considered as at rest, like this. So there is a mg force acting on it, and there is also a buoyant force acting on it, and as Fb is equal to mg, that's why it is stationary, and the net force is 0. Next part, that is C. Now this, a kite fully held stationary, again it is stationary, so I can say that force may be 0, force is 0. And let me see some content here. Can we see, yes. Okay, not this one. Okay, no. And okay, this one. Next part, a car moving with constant velocity of 30 km per hour on a rough road. Again v is, you know, velocity is constant, so again force is 0. Next, E part, a high speed electron in space far from material objects and free from the electric and magnetic fields. As it is free from electric and magnetic fields, so a high speed electron will not experience any force. A charge can experience force only either because of electric field or because of the magnetic field. So both are not present nearby this electron, so the net force will be 0. Moving on to the next question. Second, 5.2. A pebble of mass 0.05 kg is thrown vertically upward. Give the direction and magnitude of the net force on the pebble. So during its upward motion, whether it is upward or downward, it doesn't matter. We have to look at the forces on this. Okay, pebble thrown upward. This pebble is moving up and mass is given. So there is no requirement for thinking about the mass, that mass is given, we have to find out some value. There is no need for this. We have to find out the direction, and yes, for the magnitude we require it. We need to require the net force on the pebble, and that will be mg. This is net force, and its answer will be 0.05 into 9.8, and multiplying it we will get what, 5 upon 100 into 9.8. So dividing by 2 and 2, this will be 1949 by 100, this will be 0.49 Newton. This is the net force acting here, and can we see the answer also? This is nearly equal to 0.5, yes. as it is given. This point 5 is because they may be taking G as 10. Okay, now let us move on to second part. During its downward motion, it will be same, doesn't matter. At the highest point where it is momentarily at rest, no, it will again be the same. The force does not depend upon its motion here, as we are neglecting air friction. Now they are asking about, like we are throwing the pebble like a projectile, it will remain same. The force is remain same. As you can see here, ignore air resistance. Air resistance has been ignored. Okay, fine, this is done. Move on to the next question. Give the magnitude and direction of the net force acting on a stone of mass point this just after it is dropped from the window. Again, it will be the same. Net force will be like mg. Your mg will be what? 0.1 into g. If g is taken as 10, 0.1 into 10, this will be 1 Newton. Let's take a new sheet. And just after it is dropped from the window of a train running at a constant speed, again, if we are neglecting air friction, it doesn't matter. The force will be same just after it is dropped from the window of the train accelerating with. After it is dropped, the acceleration of the train will not affect it. Lying on the floor of a train which is accelerating with 1 meter per second square, the stone being at rest related to the train. Now we have to look, lying on the floor of the train which is accelerating, and we have to find the net force here. So let us deal here. There is stone here. Uh, there is stone here placed on the surface of train, and there is a normal force acting on it. There is a gravitational force acting on it. These two balances each other. These two cancels each other. So there is a friction force acting on this ball, because of which it is moving, and it will be equal to ma, as it is not slipping. So there is friction is static friction. Static frictions can be calculated by this formula. Its mass is zero point 0.1 and acceleration is 1 meter per second square for the train. So answer will be zero point 0.1 itself, Newton. So next questions in next class. You may visit visionnotes.com for other notes and queries. Have a good